Hi, welcome to this new video. This is for Leetcode number 53, maximum subarray, or sometimes referred to as maximum sum subarray of size k. So it's useful to go over some terminology right now. So a subarray is simply a portion of the array. So it could be this portion right here, featuring the 0th and the first element. It could be just one element at the middle, like that. Or it could be 3 elements in the middle. And part of what you want in this answer is that it must be a contiguous subarray. So the elements must be connected. And the actual answer is this particular contiguous subarray, which I can circle right here. And then if you add all the values inside of these 4, basically you get 7 minus 1, so it's 6. And so we're going to take a look at how we arrive at that answer. So one thing that's really useful to know is that this particular problem uses a solution called sliding window. And so what you're really going to do is effectively you're going to look at a particular element and you want to see if you use the element that preceded it and you add to the sliding window, or you discard the previous element and you start your new sliding window, and then perhaps as you move on you add on to the next element. So we're going to do a quick run through and take a look at how to look at this problem. So I guess before we do that really quickly, let's look at some other examples of subarrays. So it could be that you have a subarray where it's like -3, 4, -1, in which case, you probably just want to focus on the value here that's 4. Okay, a different example where you have maybe an array of size 4, and these 4 elements, and the largest contiguous subarray is actually just the element at the end, number 4. And so if we step through at step 0, we see that the current value is -2. And the sum, which is going to be the maximum of either the current value or the current value plus the previous sum. And you start the sum at 0. So you see that in this case, you will end up with a value of -2, because you either have what's at -2 or 0 minus 2. And the best that you could come up with so far is also just -2, as you can see right here. Now if we move on to step 1, we start to see that it's easier to make this comparison of what we want to do, whether or not you want to use the value of -2 at index 0 along with the current value, or if you just want to use, let me go back, if you want to use the previous value plus the current value, -2 and 1, or if you just want to use the current value itself. So that's basically where we are right here. And we see that obviously the best solution for the sum between, the value 1 or -2 plus 1, you prefer 1. And the same thing you do here for the best is that you consider whether you prefer -2 or you prefer 1. and of course you prefer 1. So now if you look at the next step, and here's where you get to the sliding window part. So previously the best sum was 1, so that means that you selected the sliding window to not include the value of -2. And so the previous sliding window now is just the value of 1. And you want to see if you want to extend that sliding window to also encompass the value of 3. And when you start taking a look at what you could have, it's either the maximum of the current number or the previous sum plus the current number. And obviously because right now you're at a negative number, it makes sense to continue to use the previous sum along with it. And so we continue the same thing here for what ends up being best. Now if we move on to the next step, when I equals 3, we encounter, well, you can see with your own eyes that the largest number in the array is 4. And we realized previously that because the sum had included a previous number, that the sliding window got extended. So we can see that the sliding window here consists of 2 elements, and we want to figure out if we add the number 4. To figure that out, you determine if it's best to take the current number on its own, or if you take the current number plus the previous. And obviously it makes more sense to just start the sliding window over. And so we know now that if we start over, the sum and the best values will get overwritten. So at the next step, we see that the sliding window is just the number 4, and we want to know if we extend the sliding window to include -1. And so here, I think what's actually happening is that you're kind of hedging whether or not you would or would not use -1. So you see that when we're calculating the sum, it's either using the current number or the current number plus a previous sum. And it makes sense to use the current one plus the previous, because the current number on its own is not going to be greater than what we had before. Now we see that the running best is still going to be number 4, so we don't actually update that. Now as you go on to the next step, we know that we had extended the sliding window previously over here, and so we want to know if we extend it to include this number right here. So you check to see if you want the current number on its own, or if you want the current number plus the previous sum. And we see that it makes sense to actually extend that sliding window so it's bigger. Okay, and we also update the value here for best and the value for sum. Now when you go to the next step, you see that we had extended the sliding window before, and now we see if we want to extend it again. Now to you, if you're just looking at the array, you know it's a positive number, so you know of course you're going to extend it, and you will update your best and your sum. And the video will stop here because we know that later on, with a negative number here, you're not going to include that at the end. So you will reach your destination, your answer right here. And that's it.